Lesson 3.7, multiplication and division with mixed numbers, page 221. If you remember, last section we talked about a mixed number being a whole number and a fraction together. And again, that does not mean 2 times 3/4, it means 2 plus 3/4. But what we're going to do in this lesson is we're going to multiply a mixed number and another mixed number. In this particular one, we'll be multiplying mixed numbers as well as whole numbers and all kinds of stuff through this lesson. So works the same way. Before you can multiply mixed numbers, you have to change them to improper fractions. You have to make them no longer mixed. So we're going to take this 2 3/4 and change it to 2 times 4 is 8, 9, 10, 11 over 4. We're going to do the same thing with 3 1/5. 3 times 5 is 15, 16 over 5. Okay, now we can multiply. We couldn't multiply when we were doing mixed numbers. Now that we have fractions, in this case improper fractions, we can go ahead and multiply. Alright, so if you remember, before we multiply, we would look and see if the numerator and denominators of all of the fractions we are multiplying were prime, or if they could be broken down in a product of primes. So this one, 4 can be broken down into 2 times 2. 11's prime, 5 prime. 16 can be broken down into, and then we can start getting rid of some of this. Now, if you remember, once you divide out everything you can before you multiply, once you get a final product, you're reduced. You don't have to worry about reducing it because you reduced it here. So whatever answer you get here is going to have been reduced. So 11 times 2 is 22, times 2 is 44. And you know at that point that you're not going to do anything else. You're stuck right there. It's reduced as far as it can go. But an important element here is if they give you mixed numbers and multiply them, then they want a mixed number for the answer usually. Okay, so that's just kind of a mathematical occurrence. If they start out with mixed numbers, they're usually hoping that you give them a mixed number in your answer. So we have got an improper fraction here, not a mixed number. So let's go ahead and change it to a mixed number. Get rid of some of this so I have some room. 5 goes into 44 8 times, 40, 4 left over, and we have 8 4/5 as an answer. And you can check this to see if it's right. See if it does actually, you did your division here right, because you get this back when you change it back. 8 times 5 is 40, plus 4 is 44. 44 over 5, yep, that's what we got here. So we did it correctly, so we're good to go. Alright, let's continue on here. Let's just take a whole number 3, and let's multiply that times 4 5/8. Same rule applies, only this time we have one mixed number, so we only have one that we need to change. We're going to move this to a fraction. Just put it over 1. 4 times 8 is 32, plus 5 is 37 over 8. Okay? So, 3 times 37. I can look here and I can see, yeah, there's a prime number here, prime number here. Let's see, that's a prime number. This is not. But is there any purpose in making this 2 times 2 times 2? Would anything divide out? Well, 3, I don't have anything with 2's in it up here divide out, so there's no point in writing that as a 2 times 2 times 2. You can if you'd like, but you'd end up with the 8 again. So 3 times 37 gives us 111, and that's over 8, because 8 times 1 is 8. And again, because it gave it to, the problem has a mixed number in it, we're going to change this to a mixed number, and you end up doing the math, and you get 8 into 11 is 1, 8, 31, 3, 24, 7. So my answer is going to be 13 7/8. Okay. I'm going to jump over to the next page, page number 222, do a couple of problems here, because this time we're going to divide mixed numbers. The last couple of problems we multiplied. Let's do some division. If you remember, the division is not any more difficult than the multiplication because we turn it into multiplication. Okay, so before you do anything, you change to an improper fraction. 5, 6, 7, 8. And we're going to leave our division sign. 10, 14 over 5. Okay, now we change our division sign to a multiplication sign, and we take our 14 over 5, take the reciprocal of it. So we're just going to write 8 over 5 times 5 over 14. Okay, now at this point, let's kind of move over here a little bit. We're going to move our, change our 8 to 2 times 2 times 2, put that over 5, times 5 over 2 times 7. Okay, I can divide my 5's out, and I can divide one of my 2's out, which leaves me with 2 times 2 on the top, and just a 7 on the bottom. So that leaves me an answer of 4/7. Didn't do anything that we have not done yet. We just took a lot of information that you already know how to do and threw it into one problem. Alright, let's try another one. 5 and 9 twelfths, and let's divide that by 2. 5 and 9 tenths by 2. I think I said that wrong the first time. Alright, so first of all, we're going to take this and change it to a mixed number, or an improper fraction, I'm sorry. 59 over 10 divided by 2. Alright, so if we take the reciprocal of 2, 2 is the same as 2 over 1. So it's going to be 59 over 10 times 1/2. At this point, this is a prime number. This is a prime. Alright, that 1's not going to cancel with anything. 2 is prime. 10, we can change that to 2 times 5, but what good is it going to do when we can't reduce any of the, or we can't take a product of primes of our numerators up here? So we're just going to leave it the way it is and take 59 and put that over 20. Now you can do the long way and multiply and try to figure out if there are prime numbers or if you can reduce or if there's anything you can do there. Nothing wrong with doing that. It's just going to take you a lot of time and you're not going to get anywhere. And again, we have that mixed number here, so we've got to change that to a mixed number. So 20 goes into 59 twice. 40, we end up with 19, so we end up with 2 and 19/20. Alright, so that's lecture 3.7. Next video, problem set 3.7.